Hi guys, last time on 8.3 we talked about how to solve for trig equations, right? And I told you guys for one trig function, they're usually two angle families, right? And how can we get like two of them? Well, for the first one, usually you can base on my trick of, like using the table that I usually mention in the lecture, the one with the 30, 45, and 60, and then SOHCAHTOA, so it goes like sine, cosine, and tangent. This one will give you the first angle, and then how can we obtain the second angle? For cosine, we're gonna look across to the x-axis all the way to the other side of the unit circle. For tangent, we're gonna look across from the origin all the way to the other side of the unit circle. And for psi values, we're gonna look across from the y value, from the y-axis all the way through the unit circle, okay? And then we're gonna get the second family angle, okay? And enough talking about that. Let's get into like 8.4, right? So 8.4, today we're gonna talk about trigonometric identities. Okay, it's pretty short for today. So before we jump onto like the content, let me review a little bit of like some old concepts, right? So two functions f and g are said to be identically equal if f equals to g for every value of x for which both functions are defined. Such an equation is referred to as an identity. Okay, so for example, an identity could be like, like 5 plus 1 equal to 6. Why do we say that this is the identity? Because like the right hand side and the left hand side, they always equal to each other, like no matter what happens, right? Like it's just the fact, like it's a true statement in here, okay? And then in another scenario, if I give you guys something like 5 plus 1 and I ask you guys, is this one like an equation? Are the function we have on the right hand side and the function we have on the left hand side identically equal? Well, in this case, you can say that this is not identically equal, right? Because we all know that 5 plus 1 is not 4, it's 6. So the 4 in there, it's just like like a bummer in there. So this is not a good like identity, okay? A little bit of like reminder throwback at like 7.2, section 7.2, we have a lot of identities in there. We have reciprocals, or if you want to like be casual, you can call them the flips. One C function will pair up with one non-C function, right? So cosecant goes with sine, secant goes with cosine, cotangent goes with tangent, and so on, okay? And then we also have quotient identities. So I told you a little trick about like like SOHCAHTOA. So the last one, tangent, it equals to sine divided by cosine. And because cotangent is the flip of tangent, then we're gonna flip them, right? So it's gonna be like cosine on top and then sine on the bottom, okay? Lastly, the hardest ones to remember, we have like the Pythagorean identities, right? And I told you guys, whenever you see the square in there, you have to kind of like ring a bell about the Pythagorean identities. Those are the only three that has a square in all of the identities that we learned in this trick class, okay? And a little bit from 7.4, we're gonna also have like even odd properties in there. So among like all 6 trig functions, only cosine and secant are even functions, right? The other 4, they are odd functions. For even function, if you start with a negative angle, well, we're gonna cancel that negative and return a positive angle, like nothing changes, okay? But for like an odd function, whatever odd functions you have in here, if you start with a negative angle, then we're gonna pull that negative angle like to the outside, and then the inside angle, it will become positive, okay? Again, like if you have any questions on this one, please stop it, and then please stop the video and then review them before we move on, because it's gonna get like a little bit hard to understand later on, okay? And again, if you have any questions in any like sections, please let me know, okay? Just talk to me, okay? And now let's get to the very first objective of today. Use algebra to simplify trig expressions. Okay, so here's some of my tips in here. I personally like get through this class before by like these tips. So we have to learn a lot of like algebra. Even this one is like trig, not like college algebra, I know, but still we need some like techniques from algebra, okay? So just kind of like a quick reminder before we like jump into the examples. If you stuck, make sure you always get things down to sine and cosine, okay? Like if you have like cosecant, cotangent, secant, and tangent, whatever that looks complicated to you and you don't know where to go, what to do, put all of them back to sine and cosine using like all the on the identities that we had on the last page. put everything back in terms of sine and cosine. That's like the first thing you want to do, okay? And then common sense in here, like whenever you have like two fractions, I don't know, like x divided by y, and I don't know, like y divided by x in here. Well, the common thing that we're gonna do in here is that we're gonna get to find a common denominator, and then we multiply like each fraction by whatever it takes so that they have the common denominator, and then we're gonna get the tops together, okay? So that's what I mean by, number 2, try to write expression over a common denominator to make a single quotient. So if you start with like two fractions in here, make sure you kind of like, like combine them so that at the end we only have like just one quotient, one fraction, okay? And if you you have a question about the term common denominator, here, let me just give you a quick example. Say if you're gonna have something like, I don't know, like 1/3 and then 1/2 and 4/3 in there. What is the common denominator for this one? Hopefully everyone will say that is 6. It's not like complicated to me, but it could be to you guys, right? So make sure that you ask me if you're like confused about this part, or you can just look it up, like common denominator. Look up on that, and then I will give you like a bunch of like worksheets to do, information to look at, and then things to know, okay? And of course you guys can like reach out to me if you guys don't know what common denominators are, okay? And then in here, to get this fraction become like something over 6, I'm gonna go ahead and multiply the top and bottom by 3. So 3 times 1, I have a 3 in here. And then for the second fractions, I'm gonna do the same thing but with 2. So I'm gonna have an 8 in here, and at the end, I'm gonna get 11 over 6. And if you know this one is just like a single quotient or like a single fraction, right? We get this result because we use the idea about a common denominator, okay? So number 3 in here, we call PEMDAS. So just in case you guys don't know what PEMDAS is, P is for parentheses, E is for exponent, M is for multiplication, D is for division, A is for addition, and S is for subtraction, okay? So make sure you always take care of the parentheses first. And sometimes they're gonna give you like the brackets, but we're gonna treat the brackets the same thing as the parentheses, okay? So whenever you see parentheses or brackets, get them down first, okay? Number 4, think of the conjugates, and if you don't know what conjugate is, again, you can like look it up, or else you can just talk to me and then I can give you more examples about conjugates, okay? But you only have to worry about like conjugate when it comes to like square root and then cube root and something that has like the root, okay? And if you don't know what a root is, it looks like this. Like this one is the square root of x, or like this one is the cube root of, I don't know, like 8, something like that. Whatever one that has like the root in there, that is when you have to consider conjugates, okay? Number 5. Well, this one, some of you guys might learn from high school or, like outside, but I don't know if it's like familiar to you guys. I'm giving you guys like 8 formulas in here because I think like personally they are really useful, at least to me. Just like it's really handy at times, and then just like have it there in front of you in case of like tests and homework, and then they'll help you a lot, okay? But if you don't want to remember those 8 formulas in here, of course it's an alternate way. You have to understand the concept or like the procedure for like factoring. So let me give you guys some examples about like factoring, right? So a lot of people, they call it like X method or diamond method, or even like box method. I'm not sure which one you guys have like heard of it before, but say if I'm gonna give you something like, I don't know, like 2x squared, and then what else, and then a plus 3 in here, and then I don't know, maybe like minus x in here or something like that. Okay, and I'm gonna ask you guys like okay, so first of all, wait, let me just double check to see if this problem worked out first. 6 and negative 1. 6 and negative 1. No, let me just change it to I don't know, 7 maybe. Yeah, this should work. Okay, so just imagine I give you guys a problem like this, right? And I'm asking you guys to solve for x. Well, if you minus 3 from both sides, that doesn't do anything because we have an x squared in here, and this is not like that easy to get combined, right? So it's not gonna work if we try to get like all the x's by itself, right? It's gonna like complicate the problem even more. So instead of that, we're gonna do the x method, okay? And how can we do this? Well, the middle term, we're gonna get it on the bottom, and make sure you only get the number, okay? Like no variable in here. Okay, for the top part, usually people tend to look at like the last term in here, but if you have like the front term in here, you would have to multiply the first and the last term together, okay? So in this problem, I'm gonna do 2 times 3, which is 6, and I'm gonna put it on top in here, okay? Now, our job is to find two numbers that multiply to 6, but at the same time, have to add to -7. Well, there's a lot of like cases where, you know, like the two numbers can multiply to 6, right? We have like 6 and 1, 1 and 6, 2 and 3, and 3 and 2, right? And then like -1 times -6, -6 times -1, -2 times -3, and then -3 times -2. All of those combinations, they all make 6, right? So how do we know which one like is the right one, right? Well, keep in mind that you have to add them at the same time to get -7, right? So in my mind, I'm having 1 and 6, but because it's -7, so it has to be -1 and -6, right? If you want to double check on it, -1 times -6, so we have a 6 in here. Good. -1 plus -6, we have a -7 in here. That's also good, right? So now we're gonna do the parentheses step. Okay, that is the setup, right? And then we're gonna have like 2 x's in here and in there for each of the parentheses. And then we have a -1 and -6 in here, so I'm gonna stuff them into the parentheses. It's meant to be a 6 in here. Okay, -1 and -6, right? But wait, this is like weird. Why? Why is it weird? Because like if you multiply the first terms in here, you're gonna get x squared, right? And if you check it back on the original problem, there's 2x squared, not just x squared. So that means that there's something wrong in here. How can we fix this? Well, if you have like a front number, just like this case, right? We're gonna take that number and then divide it by like each of the like numbers that we have in here and in here, okay? So in this case, the front number is 2, and I'm gonna do like a 2 on the bottom of the 1 and on the bottom of the 6, okay? So we all know that 2 cannot like go into 1 for the first pair of parentheses. I'm gonna swing it in front of x, okay? So it's gonna be like 2x minus 1, okay? When you swing it up front, that means that you're not gonna have anything on the bottom, okay? And the reason why you have to swing it is that I hate fractions and I don't want to deal with fractions. That's why you have to have like, you know, like move it up front, okay? And then for the second pair of parentheses in here, lucky enough, we know that 2 goes into 6 3 times, right? So if you simplify it, you're gonna get like x minus 3 in here, right? And let me take this out. Okay, so then we're gonna have it equal to 0, just like from before, and we set each of them equal to 0. So we having like 2x minus 1 equal to 0, x minus 3 equal to 0, and then you do like the math part for, you know, like solving for x. So let me do like the easy one first. This is like 3, and the other one is like, I'm gonna fast forward on this one, okay? So it's gonna be like 1/2, okay? But if you don't know how I get to like the final answers in here, let me know, okay? And by the way, we have like 2 answers for this problem. It's 1/2 and 3, okay? So again, let me know if this technique is kind of like confuses you. There are 2 names that you can look for like a reference. You can look for AC method. This is like one name for it, and then you can also look for X method. That's like another name that I heard a lot of people like mention in the past. Okay, so just Google it up, and then you'll see like tons of like information about them. Okay. And now let me get rid of these and let me get into the first example that we have in here. Okay, for my example, use algebraic techniques to simplify the following trig expression. Okay, how can I do that? As you can see, that's a lot from the beginning, right? But then whenever you see like parentheses, here, let me just highlight. Parentheses, what does it mean? What do we have to do in here? Well, we have to think of distribution, right? So in here, for the top part in here, because I'm seeing like the parentheses, this one and that one, right? So that means that I have to FOIL them, right? And if, in case you guys don't know what FOIL is, F in here is like first, L in here is like last, O in here for outside, and then for this one it's like inside. Okay, so we're gonna do first, last, inside, outside. Okay, so in short, it's gonna look like tangent square of theta plus tangent of theta plus another tangent of theta plus a 1. okay? And we're gonna go ahead and rewrite this one in here because, well, you know, it's from there, like from the beginning, right? So we're gonna get something like that, okay? On the bottom, there's just like one term, so like for the sake of the space in here, I'm not gonna rewrite the bottom until the very last step, okay? But in a test, make sure you like carry it like in every step that you have, okay? Like this, okay? So now, how can we simplify it? Let's see. We have some like terms in here, right? Like this one is tension and this one is not a tension, right? So that means that we're gonna have two tensions. So these two come out together and we're gonna get 2 tension theta plus 1 because like there's no other number in there. We have like a secant square and we also have like a tension square, right? If you remember what I told you about a square in the past, when we have a square, what we have to think about? Well, we have to recall the Pythagorean identities, right? Like these three formulae right here, right? And in our problem, we have something about like tangent and secant, right? So which one of the 3 that we should use in here? Well, this one is the only one that has the relationship between tangent and secant, right? And it tells us that secant square in here equals to tangent square plus 1, right? So we're gonna take that information in here and plug it in here in terms of like secant. So instead of having like secant in here, like this one in here, I'm gonna go ahead and replace it by tangent square plus 1, okay? And because we have like a negative in front of the tangent square, so I'm gonna have like a negative in front in here. But wait, this is wrong. Why is it wrong? Because secant square in here is represented by the whole group in here, not just tangent square, but tangent square together with the 1, right? So that means we have to put parentheses in here. And again, this one is like a very common mistake that a lot of people are making. So make sure you put parentheses on the group that you substitute in, okay? Like whenever you use any identities in there, make sure you always have parentheses, especially when it comes to like, you know, like negative sign there, just to make sure you guys don't like trip over anything, okay? So then I'm gonna go ahead and rewrite the tangent square in here because it's like a first term from before. But then instead of having like negative secant square, I'm gonna get negative and then tangent square plus 1, okay? So now what I'm gonna do about it, well, since we have like parentheses in here, right? What we're gonna do is that we're gonna distribute a negative in here and in here, right? So that gives us negative tangent square minus 1, okay? And again, you have to like write this one over like tangent theta, but then I'm running out of space, so that's why I'm gonna like skip that part, and then I'm gonna put it back like at the end, okay? So now what do? Well, we know that there's like a tangent square in here, and there's like a negative tangent square in here, right? So we can cancel them, right? And then there's a 1, there's a positive 1 in there, and there's also like a negative 1 in there. So, well, lucky enough, we cancel everything, right? So we end up only with 2 tangent theta. It looks short enough, right? And then there's nothing to simplify on the top anymore. So I'm gonna go ahead and put the bottom back. And then as you can like imagine what the next step would be, well, we're gonna go ahead and cancel the tangents in here. So then the final answer for this one would be just 2. I mean, like if you cancel this one, it's gonna give you like 2 over 1, right? But then 2 divided by 1 is just 2, so the answer is 2. Okay, so this one, a lot of people ask me like, how do I know what to do and then when to stop, right? I'm gonna be honest, like I have no idea like how I know how to do it. It just, you know, like by practice at the beginning, I'm just like, you know, like what is this thing? Like everything is so confused, and then, you know, like I don't know what to do. But then after I did like, you know, like 5 or like 10 prompts of this style, it just become a habit, you know, like it would just be like right there in your brain. It would just become your instinct. Okay, so just keep practicing and just keep in mind like the 5 rules that I give you guys for advices earlier for the tip parts like these, and I think you'll be good, okay? So before we move on, let me just put a green star in here to mark out that this is something that you have to do for the worksheet, okay? Now, establish the identities. Okay, in order to establish an identity, we start with a more complicated expression sign, okay? And then we're gonna manipulate it, we're gonna like control it, we're gonna try to turn it into something that looks like the other side, okay? And how can we do that? Well, we have like all the identities from the first page, right? So keep in mind all of those identities, okay? If I were you, I'm gonna print it down and put it in front of me, right? Like so that I have it like ready with me, okay? And also, like on top of that, make sure you remember the 5 tips that I give you like earlier on the last page on page 2. So page 1 is really important in terms of identities. Page 2 is also important in terms of algebra, like skills. Okay, so make sure you print like those 2 pages out. Okay. Now let's get to work. For my part, I have this like identity and I have to establish it, right? So one of the thing about like establish is that you cannot do a 2-column thing. Okay, what does it mean? Say if I'm asking you to do something like, you know, like 1 plus 5 equals to 2 plus 4, we all know that they both equal to 6, right? But you cannot give me something like this. This is not acceptable at all. Okay, if I were to give you this problem in here, the good solution for this would be something like this. Here, let me just get that out of the way before it like get into your brain. Okay, a good solution would be like you pick a side in here. So for me, I'm gonna pick the left hand side equals to 1 plus 5, and I know that 1 plus 5 in here equals to 6. And because 6 can be split into 2 and 4, I'm gonna split them into 2 and 4, which is the right hand side. And this is how I officially like prove the identity or like establish this identity. Okay, so you always have to start from one side of the identity and then you get to the other side of the identity. Okay, you cannot just do 2 sides at a time. Okay, like this is wrong. This is like not math anymore. Okay, so make sure you keep this guideline in mind. Okay, because in the test, if you just do like a 2-column thing in here, I'm gonna give you 0 for that problem. Okay, so keep in mind before you immerse to that problem for yourself. Okay, so let me take this picture out and then let me show you how the actual work will look like. Okay, all right, so for my part, I always advise you guys to start from a more complicated side. So to me in here, this is the left hand side and this is like the right hand side, right? Well, I'm gonna start with the left hand side, obviously, because it looks like horrible. We have, you know, like fractions and everything, right? So let me just, you know, like write out the left hand side, and I'm gonna copy the left hand side down. So we're gonna get something like this: 1 plus cosine minus psi theta. Okay, now what? This one I actually giving you guys like a hard one in here. That's why I'm doing it for my part, because I know that it's hard, and like, you know, like probably lots of you guys might not get this one, and that's okay. I'm not gonna throw something this hard at you guys on the tests or in the quizzes, okay? But it's just there for you know, like for us to learn, because we need to start from something hard, and then when you get like a hang of it, you're gonna get like everything like easier than that, like in an easier way. Okay, so for my example, for my part in here, first thing that I have in mind here is like everything is already in terms of, you know, cosine and psi. So, well, what can we do, right? There's no like identity between cosine and psi, because there's no square in here. There's nothing to do. Well, if you notice, the top and the bottom look quite similar to each other, right? In terms that if you treat this one like, you know, like a group, and then this one like a group itself, and then in here's like a group, and then here's like a group itself, and also, so you're gonna get something we call the conjugate. And again, like, how do I know this? It's just my instinct, to be honest. I look at it, if I see something like similar for the top and bottom, and they're different by a sign, like a middle sign here, that's the hint for me to go for the conjugate. Okay, so that means I'm gonna go ahead and multiply the conjugate of the bottom. So I'm gonna go ahead and multiply 1 plus cosine plus sine to both top and bottom of the original left hand side. Okay, and if you ask me like, how do I know this is the conjugate? Well, notice that in here we have a minus, right? So the conjugate of the minus, we're gonna change it to be a plus. And that's all. It's not like I'm copying from this side and then I make like more copy of this. No. The only reason why I having it like this is because we have a conjugate in here from the bottom of the very original like left hand side of the question. Okay. So now, how does it work? Well, it's gonna look messy in here in terms that, you know, you have to like FOIL a lot in here. So you're gonna like multiply this one in here, in here, in here, and you have to do the same thing. Let me change the color. So this one, in here, in here, in here, and lastly, you're gonna get what, psi in here, in here, and in here. And obviously we have to do the same thing for the bottom, right? So it's gonna look like really, really, really messy. Just a heads up, okay? But that's okay. I'm here with you, and this one is short, right? So here, let me just do it. Anyways, so the top part, okay. Now, if I go for the three curves in red in here, because 1 times anything would be like just that thing, right? So I'm gonna do 1 times 1, which is 1, 1 times cosine of theta, which is cosine theta, 1 times psi of theta, which is psi of theta, right? It's just for like the red ones. And now about the pink ones, cosine times 1 is gonna give us cosine. Cosine times cosine, we're gonna get cosine squared. And then lastly, cosine times psi, we're gonna get psi cosine. Or like cosine size, doesn't matter at all, okay? And I'm running out of space, so that's why I'm gonna take out this like fraction part, and let me like finish the top, and I'm gonna put the fraction back in a moment, okay? And for the blue parts, well, psi times 1 is sine. Psi times cosine, again, we're gonna get psi cosine. We cannot do anything but putting them together. The last one, we have psi times psi, which is psi squared, okay? All right, and then we're gonna do the same thing for the bottom. So the bottom, same deal, we're gonna get 1 times everything, which means it's gonna be like themselves. For the second go, we have cosine times everything. So again, we're gonna get like just, you know, from before, cosine and then cosine squared and then psi cosine, right? And I'm really sorry for the bad writing in advance. And lastly, for the last part in here, watch out for this one, because this time we're dealing with negative sign, right? So negative sign times 1, that is a negative sign. Okay, so that's a negative sign. And then next up, we're gonna have negative psi cosine. And then next up, we also have the last one, which is negative psi squared. Okay, for the work, let me put it in green because it's just, you know, like too messy right now. Okay, what can we combine or cancel on the top part? Well, we can combine this side with that side, right? And then we can also combine, what is it? This cosine with that cosine. And then, what else? We can combine this psi cos and then this psi cos, right? And then lastly, if you remember it, there's something about the square in here, and there's something about, you know, like cosine and psi being square in the Pythagorean theorem. If you go back into the first page, or if you have like all the identities in front of you, you will soon realize that cosine square plus psi square is a 1, right? And we also have like another 1 in here. So just by on the boxes in here, we have a 2, okay? So how can we put everything together? Well, first of all, this, that, and that together, they all make a 2, okay? And then cosine plus cosine, we're gonna get 2 cosine. Okay, psi plus psi, we're gonna get 2 psi. And lastly, psi cos plus psi cos, we're gonna get 2 psi cos. Okay, the bottom part, we're gonna have the same procedure pretty much. So cosine and cosine, we're gonna get 2 cos. Psi minus psi, that's nothing left, it's just gone. Psi cos minus psi cos, nothing left, it's gone again. Cosine, and then, okay, so this one, it really depends on you. Like, you can put it in terms of, you know, like cosine, and you can also put it in terms of, you know, psi. But from my perspective, because I try like both ways and I know which one works already, so let me just like skip the trial part and put it down like this. Plus 1, because we have a 1 in here, right? And then plus cosine square, because we have that cosine square in here, and minus psi square in here. And we'll soon like change this, okay? And that's from here, okay? Now let me move up a little bit so we have like more space to do, and I know it looks like really like crazy already. Now what can we do? Well, if you notice, there's something that can be factored from these two, right? They have a 2 in common, so I'm gonna factor out a 2. And then because like 2 times 1 is 2, so then on the inside we're gonna have a 1. And then from this term, if I factor out 2, I'm gonna get a cosine. And then from between these two terms, we're gonna get 2 and psi in common. And same rule, we're gonna have a 1 for this term, and for the other term, we're gonna get a cosine. Okay. And before we talk about the bottom in here, let me just skip a little bit in here and talk about like this top in here. So as you can see, like among this group, this big group now, and that big group now, we have the group of 1 plus cosine as a common thing, right? So we're gonna pull that group out, okay? And then for the first circle, because I pulled this thing out already, so I have a 2 in here. For the second circle, because I pulled this thing out already, so I'm gonna get a 2 psi in here. Okay? So now, what is next? What should I do next? Okay, so I told you guys there's something about like cosine and psi being squared, right? And if you notice, from the very first page, the identity that says that, you know, like cosine plus psi equals to 1, right? So instead of having a 1 in here, I'm gonna put it back. You know what? Here, let me just put it in, I don't know, purple. So instead of having a 1 in here, I'm gonna write it as cosine squared plus psi squared. Okay? So normal one, in place of 1, we're gonna get cosine squared plus psi squared. And in here, if you notice, this psi squared will cancel with that negative psi squared, right? And then on the bottom, we end up having 2 cosine. Wait, 2 cosine here, my bad. Because of that. And then we're gonna get 1 cos squared, another cos squared, so we're gonna get 2 cos squared. Okay? And again, between this term and that term in here, we can pull out 2 cosine, right? So for the first term, if I pull the 2 cosine out, there's nothing left. So then there will be a 1. For the second term, because we pull out 2 and cosine, we're gonna get just 1 cosine left. Okay? So now, what next? We're gonna go ahead and cancel this with that. Why? Because they're the same, right? And then for this group in here, because there's still something in common between them, right? So I'm gonna go ahead and factor out 2. So I'm gonna end up with 1 and then sine here. Okay? And then I'm gonna go ahead and rewrite the bottom, which is, you know, like 2 cosine theta, because the outer group is gone by now. So again, I'm gonna go ahead and cancel the 2's because, you know, like I can do that. So what do we have so far? We're having 1 plus sine over cosine, right? Well, we're stuck here. I mean, I'm stuck here because I don't know what to go next. So let me double check to see whether it's the right hand side that we have to find. As you can see, it's still not the right hand side that we have to find, right? But we're having something really close to the right hand side. Okay? And what do I mean by that? Here, let me keep going for this problem. Alright, so once we have this half fraction, I'm going to split them into 1 divided by cosine, because 1 is a part of the top part, and then psi is also a part of the numerator, and they all sharing like one common denominator as cosine theta, right? So I'm going to split them out. And after that, what is the definition of 1 over cosine again? Well, it's secant, right? Like it's one of the reciprocal identity, right? And for the second term, psi divided by cosine, if you guys remember the quotient identity, it is tangent. And voila, this is the right hand side that we're looking for. And the problem solved. And as you can see, this one is like really tedious and long and hard. Don't expect to see this one on a test or in a quiz, because it's not going to be this long and it's not going to be this hard, okay? But again, I'm just like throwing it there to you guys, not to like, you know, like scare you guys or anything, but just be prepared, okay? Because chances are you might see something like this, like on the final, okay? I'm not gonna like throw this hard thing to you guys on the quiz and on the first exam, but final, because it's comprehensive, chances like you will see it, you might see it, okay? And then before I call it an end, let me put like a green star for your part. So this is your part, okay? So thank you for your listening. Take care and have a great day. Bye bye.